my name is Darpan Gadia and today I present the topic of error detection and correction. Introduction to error detection and correction. When transmission of digital signal take place between two systems such as computer as shown in figure, the gate contamined due to addition of noise. It necessary to detect and correct error because this error can become serious threat to accuracy of digital system. Types of error. There are two types: content error, flow integrity error. The content error are nothing but errors in the content of message. For example, 0 may receive 1 or vice versa. Types of bit error. There are two types of bit error: single bit errors and burst error. Single bit error. The term single bit error suggests that only one bit in the given data unit, such as byte, in one error. And in burst error, if two or more bits from data unit, such as byte, change from 1 to 0 and 0 to 1, then burst error are said to have occurred. The length of burst error is measured from first corrupted bit to last corrupted bit. Important definition related to codes. Code word. The code word is the encode block of bits. As already seen, it contains message, bit, and parity or redundant as shown in figure. Code rate. The code rate is defined as the ratio of number of message bits to the total number of bit in code word. Code rate is equal to K by N. Code efficiency. Code efficiency is defined as the ratio of message bit to the number of transmitted bit per block, K by N. Error detection. When a code word is transmitted, one or more number of transmitted bits will be received due to transmission impairment. Thus, the error will be introduced. It is possible for receiver to detect this error of the received code word is not one of the valid code words. Transmitted code word 10101100. Received code word 11101100. Number of errors 1. Distance 2. Hence, to detect the error at received valid code word should be separated by a distance of more than 1. Error detection method. What is error detection method? Before thinking of correcting the error introduced in the data bits, it is necessary to detect them. For error detection and correction, it is necessary to add some check bit to clock of data bits. These check bits are also known as redundant bits because they do not carry any useful information. Some of the most important error detection method: parity checking, checksum error detection, cyclic redundancy check. Parity. The simplest technique for detecting error is to add an extra bit known as parity bit to each word being transmitted. As shown in given figure, generally the MSB of an 8-bit word is used as parity bit and remaining 7 bits are used as the data or message bit. The parity of 8-bit transmitted word can be either even parity or odd parity. Even parity means the number ones in given words include the parity bit should be 2, 4, 6, 8. Odd means the number of ones in given word including the parity bit should be odd, 1, 3, 5, 7. Two-dimensional check. When a large number of binary words are being transmitted or received in succession, the resulting collection of bits is considered as block of data with rows and columns as shown in given figure. The parity bits are produced for each row and column of such block. The two sets of parity bits so generated are known as longitude redundancy check and vertical redundancy check. Cyclic redundancy check, CRC. This is the type of polynomial code in which a bit string is represented in the form of polynomial with coefficient of 0 and 1 only. Polynomial arithmetic uses a modulo 2 arithmetic. Example, addition and subtraction are identical to XOR. This technique is more powerful than the parity check and checksum error detection. CRC is based on binary division, a sequence of redundant bits called CRC or CRC remainder is appended at the end of data unit such as byte. At the receiver, this data unit is divided by same binary number. Error correction techniques. Code are generated by adding a group of parity bits or check bits. The source generates the binary data which is accepted by encode to add the check bit to them to produce code word. Data source, encoder, decoder, destination, data bits, check bits. The encoder adds check bits to the data bits according to prescribed rule. FEC, forward error correction. In FEC, the receiver search for the most likely correction code word. When error is detected, the distance between the received invalid code word and all the possible valid code word in measure. The nearest valid code word is mostly like correction version of received code word as shown in figure. Received code word 11001100. Distance 1 valid code word 111011100. Distance 2 valid code word 2 11101101. Distance 3 valid code word 3 11110100. CRC checker, the code word at the receiver of data and CRC. The receiver treat it as one unit and divide it by the same n plus 1 bit divider which was used at transmitter. The remainder of this division is then checked. If the remainder is 0, then the received code word is error and free and hence should be accepted. Not non-zero remainder present of error as hence corresponding code word should be rejected. ARQ techniques. There are two basic systems of error detection and correction. They are automatic repeat request, forward error correction. In ARQ system, when error is detected, a request is made for the retransmission of that signal. The point difference ARQ and FEC are: in ARQ system, less number of check bits are required to be sent. This will increase the k/n ratio for block code if transmitted using the ARQ system. A return transmission path and additional hardware in order to implement repeat transmission of code words will be needed. Block diagram of basic ARQ system. Message sent to encoder and encoder input buffer and controller. Then message was passed by forward transmission channel. Then message was detected and sent by output. If acknowledged or is happened, then return this message to feedback path to forward transmission channel. Operation of ARQ system. The encoder produces code words for each message signal and its input. Each code word at the encoder output is stored temporarily and transmitted over the forward transmission channel. At the destination, a decoder will decode the code word and look for error. If decoder doesn't get error, then it is positive, and if he gets negative, then it's negative. Thank you.